I'm Pen Haddow and I'm the leader of the Catlin Arctic Survey, which was partnered with WWF International. It was very tough, physiologically and psychologically. The temperatures were below -30 degrees, between -30 and -45 degrees centigrade as an ambient air temperature for the first 50 days. And just when the temperatures, actually they warmed up very rapidly, as is often the way there, just as the temperatures eased, the sort of mental burnout started to take over of having to have worked and focused and overridden the sort of hypothermia issues for so long. So we were never comfortable. The core program was to drill manually through the sea ice and to also, and essentially to measure the thickness of the ice and the density of the ice, and also the thickness of the snow on top of it and the density of the snow. We made about 1,500 observations as part of that program over the course of the 440-kilometre survey route that we did over 73 days. We also made about 15,000 observations recording every single surface feature along the route that we encountered. Every ice flow, every pressure ridge where the flows crunch together to throw up chaotic jumbles of ice, every ice rubble field and every stretch of open water. That's never been done before. What we do know at this very early stage is that the average thickness of the sea ice along our route was 1 metre 77 centimetres. We had been led by the scientists that had advised us on the route that would be most useful to them, that we could expect a good mix of the older, thicker ice, multi-year ice as they would call it, and the younger, thinner ice, first-year ice. What we found, despite what some computer models would suggest we should have found, and indeed despite what some of the satellite image interpreters were suggesting we would find, is this younger, thinner ice, almost completely. We were not exploring the linkage between sea ice cover and global climate change, but in enabling the scientists to understand better the sea ice, inevitably it improves our understanding of the relationship with global climate change. I have just played our sort of small part to try and help a better understanding of what's going on up there. It's a fearsomely complex environment with remarkably little actual observations taken at the surface, and that's really what needs to be done more as a matter of urgency. You know, everyone accepts that global warming is happening. There is no dispute that the area of sea ice by the end of the summer times on the Arctic Ocean over the last 30 years has been steadily declining. There is a high probability that it will become a seasonal feature only on the surface of our planet, this ice cap, if you will, on the top of our planet. One of our planet's defining surface features from deep space. And it would be an unwise person indeed who could not envisage how losing an ice cap, which acts as a protective heat shield for the planet, cannot have any effect on both climate and people, and therefore people, and of course wildlife and habitat. All the information that we've collected, 15,000 observations, the 1,500 measurements of the ice, it's going to take some time to process a lot of that information before it can even be viewed usefully by scientists. Findings will emerge over time. Some of it will be available ahead of the Copenhagen Conference of Parties discussions. Indeed, we hope some will be available in the next 3 months. And working with WWF, we hope that you will all be able to use that to good effect to enable better informed global policy on greenhouse gas emission controls.